We've got Don and Wes in the studio today to help us understand what the KRACK and ROCA vulnerabilities mean to you, starting on the ITProTV podcast right now. All right, thank you for joining us on the ITProTV podcast. Today we're talking about something that's really important to pretty much anyone out there who's using the internet over Wi-Fi, which I know is most of you, and we've got a couple of great experts here to help us out today, Mr. Don Pezet and Mr. Wes Bryan. Thanks, guys, for joining.
Absolutely. Thanks for having me.
Yeah, so we've got actually two different unique things that both happened to come out yesterday. Let's just go ahead and start, Wes, with you. What is KRACK? I hate to even ask, but
I know this is an interesting conversation for sure. This is what's known as a key reinstallation attack. It's actually it was addressed a few months back, July or August. So it's been around. It was just first now. They're making it public to the rest of the world, probably to give vendors a little bit of time to try to patch or get ahead of the formal release of this information. So essentially what it is it takes one of our most secure protocols, the one that we really, really rely on in just about all your wireless networks today, and it's found that there is a weakness in it that an attacker could potentially take this protocol, WPA2 we're talking about, right, the Wi-Fi protected access, version 2, if you will, and can exploit it and can potentially take what we think or thought was confidential information and expose that and get access to it.
All right, and when you say this came out earlier, so if I'm understanding kind of the timeline right, it sounds like it was discovered by not malicious people, but people that kind of were on the security side, and they realized it and let the major vendors know so they could patch it before they let other people know about it, so that the bad actors weren't going in and getting in people's information. Is that correct?
Absolutely. I don't know exactly how to pronounce his last name, but it's Matthew Van Hoff or something.
Yeah, I looked him up over in Belgium.
I'm probably not pronouncing the name right, so sorry out there, Matthew. But yeah, found this and made it vendors aware, and some vendors were made aware as far back as July. I know the Computer Emergency Response Team has a formal awareness of August 28th, I believe, of 2017. So it's been around for a little bit now, and now it's been released to the public. So, yeah, they've been aware of it for a little bit.
So we'll jump back to a little bit more about KRACK in a second. But if that wasn't bad enough, if you didn't have to just worry about KRACK, then ROCA comes out, and now we have KRACK ROCA on the same day. It's too terrible to laugh at, but it's also not. But Don, can you tell us a little bit more about ROCA? What does that stand for? What's it all about?
All right, so ROCA it stands for Return of Coppersmith's Attack, and it's actually a very old exploit. It potentially has been around for 5 years, only detected recently though. So it's one of those that hopefully the security researchers are the first ones to find it. And they find it, they reach out to the vendors, everybody patches it, and it's all patched before it comes out in the wild. But the reality is that attackers could have learned about this one as far back as 5 years ago and been taking advantage of it. It is a key attack. So it basically breaks down the trust model of a public key and private key. And it's tied to Infineon chips and the way that they generate private keys, that if you've generated keys using those chips, it can result in a public key that can be reversed to calculate out or to factor out what the private key is. And that completely breaks the public key, private key model, which sounds really, really bad. A little later in the show, I'll talk more about it and kind of tell you the limitations on it to make you realize that it's not a full-blown panic. It's not that all private keys are now compromised. It's definitely much more limited than that. You wouldn't know from some of the headlines out there. But we'll take a look a little bit more at that as the episode goes on. But definitely different than KRACK, although kind of, this just sounds ridiculous, doesn't it?
It worse.
But kind of related in that they both work on trust exploits. They both are able to compromise encrypted data. They both compromise a private key. KRACK does it by basically replacing or reasserting a key. With ROCA, it's actually figuring out what that original key is. So we don't even need to replace it anymore because now we know what it is. But the end result of both vulnerabilities is that you're able to decrypt encrypted traffic, and that's a problem.
Yeah, that's scary.
So is this just a coincidence that these both happen to kind of come out publicly in terms of in the press yesterday? These sound unrelated.
Well, with this one, and Wes, you can probably better answer this because with ROCA, there's really just one CVE for it, right? There's one vulnerability, but with KRACK, how many are there?
There's like 10 of them. Yeah, they're pretty long. In fact, let me just give you, so every one of these CVEs, that is the common vulnerability exposure, I believe, is the CVE. Yep. And they all start with a CVE-2017, and you can definitely look some of these up. But they start in a 13077. And sequentially all the way up to 13082. So we're literally talking about 77, 76, 8, 9, 80, 81, and 82. And, if you go up to a place like, for instance, the Computer Emergency Response Team, like you see here on your screen, you can see there's quite a few because it really does. It takes advantage of the handshaking process that happens to establish an encrypted communication on your wireless network. And there's a lot of different places that they can actually do that, again, by a little bit of packet manipulation on your wireless networks. What should be a one-time use key can actually reuse something known as an already in-use key. So there's, as you can see here, there are a bunch of them out here. We've got, what else, 13084 all the way to 13086 to 13088. I mean,
Yeah.
It is a laundry list, as you can see.
And so, I like to think that it is kind of coincidental that they came out at the same time, but there is a little bit of overlap between the two. Not a ton, because really with KRACK, it is focused on WPA2, right? I mean,
Yes.
you're really
Yep.
focused on one protocol versus ROCA, where it's focused on the private keys that might be being used for WPA2, right?
Sure.
But are more likely being used in plenty of other places. And the biggest risk area there are TPMs. So,
Yes.
definitely a different application. I would say that it's mostly coincidental that they're coming out at the same time.
Sure.
And now something I was reading in the on Twitter when this was first coming out yesterday was a lot of people were talking about Android when it came to KRACK. Is this something that's exclusive to Android, or is that kind of a misnomer here?
It's interesting. Android 6.0 and higher, they're more susceptible, and it's just the way that they can basically reset what we call the nuance, I think they call it. Sometimes they call it our initialization vectors, and they can reset that. So they're a little bit more susceptible to the attack. So most Android phones 6.0 and higher, and even some of the Linux distributions. But when it comes down to it, it's not just isolating Android, which is really scary. It's almost every modern computer, because when you look at it, the attack isn't restricted to any one device or implementation on how they implement WPA2. It's actually underlying in the protocol. So we're talking the protocol itself.
Yeah, and we've got to be careful with how they're measuring this, right? Because they'll say like one OS is more vulnerable than another. The tricky part here is where they get their WPA2 negotiation from, right? Most Linux and Android distros, they're using the WPA supplicant from the OpenBSD team. And that one is known to be vulnerable.
Yes.
So because we know that's vulnerable, we know that most Linux and almost all Android systems are vulnerable. And they're really high risk because how often do updates come out for your Android phone? They're a lot better now, but not
Still
perfect
slow.
by any means. Yeah. Versus on Windows or on Apple, where, hey, they detect this attack, they push out an update, and they get it fixed. And so some versions of Windows may be affected, but really it comes down to the network drivers that are being put in use to be able to negotiate out WPA2. So we don't have a 100% you're vulnerable if you're running this OS type designation, but a lot of people are vulnerable because where they're getting that supplicant. And I thought it was really interesting that it was the OpenBSD team's implementation that was like known to be vulnerable, because they do such a good job of poring over all of their code, making sure it's secure. I remember when Heartbleed broke out and OpenSSL had this huge, massive vulnerability in it. And the OpenBSD team said, that's it. Forget you guys. We're going to create LibreSSL, and we're going to pick over it and make sure it stays secure. So here's a team that knows what they're doing, but this particular vulnerability just went unnoticed for a long, long time.
And as I'm sure you're going to let us know a little bit more about the ROCA and more of the specifics here, I want to kind of leapfrog off of what you said earlier when we began the podcast. We have to understand, the gravity of this type of attack. Understand, it doesn't mean that it's doom and gloom for everybody in the entire world, that the whole entire internet is now privy to your information. It's a Wi-Fi attack. All right, so what do we have to have, that'll allow a successful exploit? Well, they got to be in the proximity of your wireless network in order for that to happen, right? So, yeah, there's a lot of things that can happen with this attack, especially when it comes to encryption and being able to decrypt the information. Some of the attacks that they see there, we see things like, for instance, replay attacks, right? We see man in the middle, reading all your encrypted information. So you do want to use additional technologies as well, things like HTTPS, to make sure that you're negotiating additional encryption. But when it comes down to it, the scope of this is really the attacker has to be within range of your network.
And I thought it was pretty interesting how this can all be done almost invisible to the user, right? So when you connect with WPA2, there's a four-way handshake that happens. And in the first two parts of the handshake, you're authenticating. And so you're already authenticated by the time you get to the third part. And in the third part, you're exchanging a nonce in order to set up what's effectively the private key you'll use to encrypt all your data. So an attacker exploiting this, they can one of the implementations, the proof of concept that I saw, showed where they could basically reset your encryption key to be all zeros. Mm-hmm. And so once that's done, they now know your encryption key. They don't have to authenticate, and that's important because that means this works on pre-shared key like WPA2 Personal, but it also works on EAP or your WPA2 Enterprise. That even if you've got certificate-based authentication, this is after authentication, so that doesn't help. And if they've reset your encryption key to 0, they can now not only decrypt and read everything that you're transmitting, but they can inject, and yes, they do all this seamlessly. The only thing you would see on your laptop or phone or whatever is you jump channels. And when you jump channels, your machine does that all the time anyway. A lot of routers and stuff do this automatic to find the most uncongested frequency. And honestly, you might even jump back to the original channel, not even notice it. Now your data is all basically free and clear. So I'm glad you mentioned it, Wes, that if we couple this with another technology like HTTPS or a VPN is even better, mm-hmm, now you know your data is a little more safe. But those protocols have had problems in recent years as well, haven't they?
Yeah, and that's one of the things that makes the Android devices is that null value, resetting that key to that null value. It's easier to do in the Android 6.0, so that's one of the reasons they're saying, hey, these are most likely going to be affected. But really, when it comes down to it, any unpatched system is going to have that issue.
Yeah, and I know I saw one article where they're saying, Android 6, come on, Android 8 is out.
Right.
But the reality is, like, Android 8 is only on 1% of Android phones or something like that. Even Android 7 isn't as widely adopted as we'd hope. And
sure, for
a lot of people, they buy a phone, it comes with Android 6, and the vendor never pushes a single update to it. So now they can't fix it. Mm-hmm. And this is really a client-side problem, not so much an access point problem. Some of the access points are being patched to fix it on their side, but there's 10 different CVs, 10 different ways of performing this attack. Mm-hmm. That's a real problem for Android phones that aren't getting updates.
Most definitely. And a lot of the major vendors, you mentioned it already, like Windows and Apple, they're good about updating their systems, believe it or not. If you are, and in fact, I don't know, Don, do you have a knowledge base article? They actually let, Microsoft has released a patch to a couple of apps, a couple of these attacks already that we've been talking about, and you can't really see it. Look at all this information; it was kind of hidden. It slid under the wire. If you'll scroll all the way down to that article right there, you'll see some of the things right there. That last bullet point is really what we're focusing in on, and if you have the current update, right, the cumulative update, it's 2017, and you'll see that it fixes a lot of these things that we're talking about, and hopefully patches it. You'll notice that in there they have things like Don was mentioning, the TPM, Windows TPM. So that update is intended to fix the ROCA attack, device guard. But notice that there's Windows wireless networking in there. And that is the KRACK side of this. Boy, that doesn't get any better for sure. But you can see that they kind of slipped that one in there. And if you are automatically updating your machines, well, guess what? You're already patched for both of these attacks, which is a really good feature. And Apple is mentioning that a good majority of the iOS, the Mac OS are updated, but some of their other Air technologies are still a little bit slow to receive this. So we got to be diligent and just keep up to date with it.
Yep, and you got to remember all your other devices that you might have a wireless printer, yes, wireless refrigerator, all these IoT type devices. They don't get updates at the same speed as some other things like our desktop operating systems and even server OSs. although on servers we don't normally use wireless, so not such a big deal there. But just because your individual communication is fine, there might be other communications on your network that are still vulnerable.
Most definitely.
Yeah, so it sounds like I was premature to take a baseball bat to my Wi-Fi router at home, and I forgot about the printer. I'll have to do that tonight.
Yes.
But it sounds like this is kind of taken care of in terms of those patches are available, and that's what you need to do. But can you maybe let's start with KRACK and then talk about ROCA. But what are the steps that I need to take as an individual, first of all, to make sure that just my home network is safe, but then as a system admin, maybe in an office, are there other things I need to do, back in the server closet and other devices I need to make sure are patched?
Yeah, definitely. Basic security hardening techniques, making sure that things like your firmware is up to date, that if you are doing updates in your Windows device, just check with Windows updates. Go into your Windows operating systems, because the patch that they released, it updates, for Windows specifically, it updates things like Windows 7, Windows 8, and Windows 10. So all in one. You want to make sure that if you're running those operating systems that you're applying your updates. And I would say the same thing inside of the App Store for Mac OS. Make sure that you're updating. The other thing too is that they do have vendor lists out there for vendors that have been affected by this. The Computer Emergency Response Team has these, not only the CVEs, but also has a whole entire list of vendors. And I wrote some of them down. Believe it or not, Don, you mentioned OpenBSD. They're actually touting that they've got a patch in place right now, ready to be downloaded. Patches are available. Ubiquity Networks, I know that we use Ubiquity. They've got a new firmware update that's out there. It's update 3.9.3.7537. So what we're saying here is get in, and if you have these devices like Linksys, because those are common in the home networks, that you're checking with the manufacturers' websites and seeing if they're pushing out these new firmware updates. Google is one that they said, hey, we're going to, in the next few weeks, we're going to be releasing one. I believe the Pixel phone is set to update as early as November 6th. So you have a lot of the vendors out there. Intel put out an advisory note, and a lot of their chipsets, again, that are susceptible. Some of their wireless AC controllers are susceptible to this, and they've already got updates and a full list with the systems that are affected. So just do your due diligence, and if you've got these devices on your network, make sure that you're updating the firmware. Don, you mentioned IoT. A lot of times we don't update IoT. When's the last time you've turned your TV on and gone to the system settings and said, hey, let me check to see if there's a firmware update? That's going to be something that you're probably going to want to be doing as a result of this kind of information that's now out there in the wild.
Okay, so let's say I'm a layperson, because I am, and let's say I go home and I've patched my computer. I've gone ahead and if it's a Microsoft, I've gone ahead and run the updates, and I've so it sounds like I need to do something on my router as well, and make sure I've patched something there. And if I do that, do I need to worry about the other things that are accessing the internet through that router then?
Well, I mean, I guess one of the things that you would do with your router, most of your routers have some kind of web interface. Again, going to the manufacturer's website, you can log into it, and a lot of times they got a setting that allows you to check for new firmware updates, and then you can, they make them easy. Sometimes they're a little bit more complex, but for the most part, it's really just push and click technology. And then once you have all of your firmware, all of your operating systems up to date, you should be good. It should close off the vulnerability.
All right, so what about Don on your side now with ROCA? Same basic steps? I mean, it sounds like some patches exist. Or?
Well, all right. So ROCA is a different beast, right? So let's talk a little bit about it and why it's different. ROCA is not so much a software exploit as it is a hardware. And hardware, you can't patch. You can't just swap out that chip, right? So the problem here is that Infineon, it's a company that makes the chips that are used to generate private keys. Their chips are used in a number of products so that you can generate a private key on the chip instead of on your own device, right? So, for example, I've got a machine here in front of me. It's running Linux Fedora, right? So I can generate private keys really easy. And in fact, my CPU is an Intel processor, so it's got AES acceleration in it. I can generate keys really easy. But if I didn't trust this machine, if I thought maybe the machine had been tampered with, I don't want to generate a key on it. So I might have something like this. This is a YubiKey, a YubiKey 4, and it has a chip on it. It is actually affected by the ROCA attack. So the chip on here can generate the key for me. And so I can plug this into a computer I don't trust, and I can tell the key, this thing, to generate the private key, public key pair for me. And once it does that, the Infineon chips use a system to generate a private key that is not truly random. And that in some scenarios, not every scenario, but in some scenarios, it can generate a key that has primes that are reversible, that are factorable. And so an attacker can take the key and then run it through a series of models and or they can take the public key, run it through a series of models, and then potentially generate what the private key was off of that. They never actually get the private key from you. They generate it purely off of your public key. And the danger here is if I generate a public key, I give that out to people. It's public, right? So let me tell you a true story. So in my hand, I'm holding a YubiKey 4. And last year, I generated a key on this device. It's part of like a how-to video. I actually use a YubiKey Neo normally, but I use this one in the show. And I generated a public key, private key pair for GPG, right? So if I want to send an encrypted email to Wes, I would encrypt it using this private key. Or sorry, other way around. If Wes wanted to send me an encrypted email, I would give him my public key. He could encrypt the email using that public key and send it to me, and only I could decrypt it because only I have the private key. Well, now, Peter, you could intercept that email, and my public key I give out freely, right? So you already have my public key. You could then factor my private key and decrypt the email that Wes sent, right? So you could gain access to that, breaking the trust model. And there's not a great patch for that because you can't patch hardware, or at least usually you can't. So the trick here is two things. One, not every key is affected. So there's a really good chance that the key you're using isn't affected. And I was really lucky in that the key I used on this show, I actually saved it. And let me show you guys here. I'm going to bring up a website. So this is keychest.net/ROCA, ROCA. And on the Keychest site, they've got a ROCA test where you can throw your key in there. And so I took the public key. This is the public key that I generated. It was well over a year ago, so way back in 2016 at some point. Here's the public key, and I fed it in there. And it runs a quick series of tests on it, and you'll see that it ran 2 tests, and it found that I had a PGP key. That's exactly what I was using it for. And in this scenario, it's showing that my key is safe. Oh, here, you can see I generated it March 6th, 2016, right? So it's a year and a half ago I did this. Actually, I did 4K. I did a nice strong key on this one. And it shows that it's safe and I'm in business, okay? So even though I know for a fact that this key is affected, I don't have to do anything. I don't have to patch anything, right? But if I ever regenerate a key on this device, I need to test the key to make sure that it's safe. Or maybe they find some way to fix this key, but the odds are what they'll do is in the software. In the future, they'll generate a key, test it. If it fails, they'll just generate another one. If it fails, generate, until it generates one that is safe, that doesn't have primes that can be refactored. So this is a lot different. And in a way, I think it's more dangerous. In fact, if you look at some of the headlines that are out there, I had this article up a second ago here. Forbes is saying, worse than KRACK, right? Google and Microsoft hit by massive 5-year-old encryption hole. I think the main reason we might say that it's worse is just because if you're using this on a TPM, a trusted platform module, that's the one chip in your computer you're supposed to be able to trust. And here we've got the scenario where you can't trust it, right? So that's kind of the main, the key problem to the issue. I'm awesome.
So that brings up a good question for you then, Don. It sounded like with KRACK, it wasn't necessarily we found out about it because someone was hit. We found out about it because some people were doing due diligence, and we were able to patch this before it became an issue. This, you said with ROCA, it's a 5-year-old thing that's reemerged. So first of all, how does something reemerge that we were aware about 5 years ago? But second of all, did we find out about this because Microsoft and Google were actually hit in these cases?
So we don't know of any attacks yet that have taken place in the real world. So what it looks like so far is that researchers found this. Researchers announced it to the community, privately, and then did full disclosure after a reasonable period of time for people to patch. As far as the reemergence, the attack itself was discovered 5 years ago and fixed. And this is a reimplementation. It's a slight variation of that attack. So it's not the exact same attack. It's not like it just went 5 years unpatched. But they found a different way to apply it. And it exploits a particular library, which I think I've got around here somewhere, the RSA library version 1.02.013, which has been out for 5 years, right? So they just discovered it now, but they know that library's been in use a long time. So that's how they know that this attack has been there. And again, just to put a little more kind of a realistic level on this thing. First off, not every key is compromised. It's less than half, right? So it is a small number of keys that are affected. And then on top of that, I think the guys over at Ars Technica did a great job with this, because they said, all right, let's say you wanted to pull off this attack, because it's a proof of concept that's released. So if you wanted to actually pull it off, let's say I got one of Wes's public keys and I wanted to pull it off. If Wes was using a 1024-bit key, right, which you just saw I was using a 4096, a 4K. So if you're using a 1K key, it would take somebody, if they spun up Amazon EC2 instances, it would take them 45 minutes, and it would cost about $76 in computing power to factor out the primes to figure out what the private key was. That's pretty bad, right? But who uses a 1K key? In fact, the UB key that's affected, it defaults to a 2048-bit key, right? So at 2048-bit, it would take, again, using AWS as our platform, it would take 17 days and $40,300, right? So for an attacker to pull this off, they'd have to have a lot of resources. Now, that's the worst case scenario. So let's say that 50% of the time we find the key in the first half of the attack. So it's still $20,000 over 17 days. If we spread that out, right, maybe 34 days and $10,000, or 68 days and it's $5,000. It's still a lot of resources. So it's a hard attack to pull off. But if you're a nation state, you've got those resources, right? $40,000 to the NSA, that's nothing, right? They spend $40,000 just intimidating witness. So that's not a big deal.
That's a whole different podcast.
Yeah. So that type of attack is reasonable. But my key was a 4K. Now, that's because when I generated the key, you can override it with the command line. So I just took the time to do that. So there's the real solution. If your key is affected, you could just keep regenerating keys till you got one that wasn't affected, or you just pick a stronger one. That no matter what security technology you pick right now, 2 years from now, it's not going to be safe anymore. So you always want to pick something stronger if you can. Plan for the future. Plan for people being able to break your key, and then you're a lot better off, right? So that's really important as kind of a fix here. If I used a gigantic key, a modulus for my key, then it would take years upon years for an attacker to break it. And by that point, one, my communications are obsolete if they saved them. And two, I've probably moved to some new technology by that point, and that's the real solution.
Yeah, one of the things that they're, with KRACK that they're talking about is that if you have important information, just send it over a wired connection. If you're really worried about it, because I don't think anybody really cares about my information enough that they're going to spend $40,000, So, just be smart about your over-the-air type of communications. And if something is that important, then you're going to want to be using HTTPS, where the browser and the servers, they set up the encryption, so it's outside of what the flaws in WPA2. And it doesn't make WPA2 obsolete either. In fact, if you're part of the Wi-Fi Alliance, where it's a consortium of wireless vendors, and they promote their wireless standards. The Wi-Fi Alliance has actually issued out to their partners a crack detection tool, so that you can run and you can find out if your implementations, your devices are actually vulnerable to this.
And I'd go a step further. I don't trust HTTPS, because
Right.
TLS already, SSL 1, 2, and 3, they're all broken,
Sure.
right? TLS 1.0 broken. Mm-hmm. TLS 1.1 is theoretically breakable in many scenarios. So TLS 1.2, that's really the only one you can trust anymore. So they just keep kind of falling apart. Mm-hmm. So I say stick a VPN on. If you're on a wireless network, use a VPN, and then you don't necessarily care about what underlying encryption algorithm they're using, or whether they're using one at all. Hell, you use WEP or plain whatever.
Sure.
You got a VPN tunnel and stuff, and it gathers everything. If you rely on HTTPS, there's a lot of things like your DNS queries that aren't being encrypted, right? You don't do an encrypted connection to a DNS server. It's plain text. Somebody could do a DNS hijack on your traffic, and you think you're safe because you're relying on it. Don't rely on a single protocol like HTTPS. Make sure you use something that's a session-based,
Sure.
or not session, but transport-based, that protects your entire communication. I think SSH tunnels, VPNs, IPsec, those are all great solutions, and you can ratchet up the strength on those things and protect your data over wireless.
So even if I've patched my machine, if I'm at a coffee shop and I'm on a public network, if I'm sending anything at all secure, I want to be on a VPN. Is what you're saying?
Yeah, that's what I do when I'm at a hotel, when I'm at a coffee shop, when I'm at a conference. I get on the wireless, regardless of whatever technology they just gave me. I fire up a VPN, and usually I'll VPN in back to my home or VPN back into the office, and so I've got a safe launching point. But if you're browsing out to the internet, it becomes unsafe really, really quick. Yeah. But you could even just use one of those VPN providers that are out there, like ProXPN or NordVPN or one of those guys. At least that gets you over the wireless secure. Mm-hmm. Once you hit them, you're not really safe anymore because you're back on the internet. But at least the wireless portion was safe. And honestly, you can't trust shared networks anyway. If you're at a coffee shop, somebody's right there. That's when you're the most vulnerable.
Yeah, and the underlying technology, somebody might say, well, just change your password. Well, it's like you mentioned, it really has nothing to do with a password. You can change the password all you want, and it's not going to make your wireless communication safe. The other thing, too, that we talk about, all of the underlying technologies that WPA2 uses, well, WPA and WPA2 are susceptible to this type of attack. I mean, it's TKIP, Temporal Key Integrity Protocol, that came into WPA, and CCMP is vulnerable. AES CCMP is vulnerable as well. So like you said earlier, the enterprise level, the personal levels, or modes, if you will, they're all susceptible to this. So people, again, just have to pay attention to the manufacturers and the vendors. And over the next few weeks, we'll probably see a lot of security patches coming out.
All right, so one more question we got. We're actually streaming this on Facebook Live now, and we had someone ask about firewalls. Are those going to be affected? pfSense, Cisco, anything else that we've got in our closet?
We were talking about this a little bit before the show because my first answer was no, right? Because in my mind, I think enterprise firewalls, and enterprise firewalls don't have wireless, so they're not affected. Maybe they have a TPM in them for local encryption, but usually in those cases they don't use it. So so most firewalls are not going to be affected. But Wes, you reminded me that a lot of firewalls these days, like the branch office type firewalls, or the end user, the home user type firewalls, they have wireless built into them so that they would be affected, right?
Absolutely. So pfSense, it's an interesting, the list that you showed earlier with at CRT there, they don't have pfSense on the list. So that is a good thing, but like you said, if they're protecting a wireless network, that means they are susceptible to that same.
So after you told me, I started to do some lookup. So at home, because here at the office we have pfSense firewalls, but they don't have wireless in them, and they don't use their TPMs, so they're unaffected by all of this, right? But at home, I have a WRT 1900 ACS, right? So, one of those flashable routers, and it's a Linksys router. And I looked at Linksys website, and they have not released an update for it, right? And they're not good about updating their routers anyways, but it'll be a while, if ever, that they release an update for it. But I've actually flashed mine, and I run Untangle on it. You're familiar with Untangle Firewall?
I've never used it, but yeah.
So they released a firmware version that can run on a WRT like mine, and so that's what I do. I run the Untangle Firewall, and they already had a patch out for it. In fact, I had auto updates turned on, so it's already fixed, and I didn't even have to mess with it. So some firewalls are affected. It's mostly going to be home and consumer-based firewalls. Just because enterprise firewalls don't normally have wireless. So that's going to be the big thing. When you're in an enterprise or a corporate environment, you have wireless access points and you have firewalls. They're two separate things, But in a home or small business, that's when we start combining devices, and that weakens your security.
Yeah, and Cisco, you mentioned Cisco. Cisco's put out an advisory notice with all the CVEs and stuff and kind of what they recommend doing there. So you can always check that information out. There you go. There's the article. And they say, hey, we're aware of it, and we're, moving forward with trying to implement patches and fixes to, give the customer solutions in the enterprise level as well.
Yeah, so it sounds like end of the day, make sure you've patched your devices. Make sure you've looked for those updates out there. And it sounds like a good rule of thumb regardless to use a VPN, use one of these other kinds of tools to go ahead and secure your data until there's a hack on that, and then at that point we just go back to smoke signals because I don't know what we'll do then. But we'll cross that bridge when we come to it. But any other points you guys wanted to point out before we wrap up today?
Well, with the KRACK attack, one of the things that I heard somebody mention on one of their blog posts says, update your clients, because even though maybe you've updated, your home router, update your clients, because your client devices go on other networks that might not be updated. So you want to make sure that all of your client devices, your phones, your tablets, your computers, make sure that you update them, because just because you've taken care of your network, when your device connects to another network, that network might not be updated and it might be susceptible to the attack. So the best thing that you can do is try to just cover all your bases.
Yeah, I'd add to that, as long as you've updated your workstation or your laptop or whatever, you're fine. If you have an Android phone that doesn't have an update, then when you're out in the public, just don't use Wi-Fi. Or if you do use Wi-Fi, bring up a VPN on top of that, right? And hope that your phone gets an update to fix that. Unfortunately, the Android world, I love Android, but you just don't get updates as reliably. I guess if you have like a Pixel or a Samsung phone, those update pretty fast. On the ROCA side of things, remember that most keys aren't affected. And you can go to the KeyChest website and test your key, so it may be a non-issue for you. Make sure on the KeyChest site that you use your public key, not your private key. If you upload your private key, that's bad. So test your public key. You're probably fine. Most people are. But if you aren't, regenerate your keys, right? And know that any data you encrypted in the past using that key may no longer be safe. So you may need to get in there and redo that. Both of these issues are bad because they're so widespread, but they're not like panic worthy. We're not at that point where we say, that's it, screw it, turn it all off. We're done with computers. We're not at that point for sure. But it's easy to kind of get the runaway headlines that are out there, the sensationalist headlines.
It was chaos yesterday, it looked
Yes.
like. Yeah. But Nancy Reagan, I think, said back in the early 80s, the crack is whack. And,
That's right.
And I think we see
Just
that
say
this,
no.
this holds true today. Thank you, though, for that information, because it did kind of put this in perspective to see that the world isn't burning down and we don't need to eliminate all wireless from our homes, that there are steps that we can take. And in a lot of cases, those steps are already taken for us, which is really helpful. But it's definitely important to understand this as well. But thank you guys for watching. Thank you, Don. Thank you, Wes, for your help today in explaining this to everybody. We'd ask that you at home, if you can take a moment and make sure you subscribe to the podcast, share it with a friend if you like it, and go ahead and leave us a comment or a review on iTunes, on Stitcher, on TuneIn, Google Play. Those are the places that people find us, and if we get those reviews there, that definitely helps us move up those rankings and get some more great viewers like you. So thank you so much for tuning in today, but we're going to go ahead and wrap this one up. So I'm signing off for the ITProTV podcast. We will see you guys next time.